everyone, this is Hesam and welcome to a Houdini tutorial. In advance, I apologize for the stutters I might have. This is my first tutorial, so please bear with me. Hopefully I get better in the future. One thing I want to try is that I usually work while listening to music in our studio Kodan, and I also wanted to try that with the tutorial. So please give me your feedback and comments. Hopefully this turns out to be a good feature. What we're going to listen to today is an album by the Canadian ambient and drum producer Kyle Bobbidan, and the album's name is Kyle Bobbidan and the Infinite Sadness. This is the Bandcamp page, and this is the album art in case you wanted to follow him. For today, what we're going to talk about is making your own HDA, as they call it in Houdini, which are the reusable digital assets in Houdini. And for that, one thing we should first figure out is that we should have this process or set of processes that we want to pack into one node and then turn that into an HDA. So for today, what we want to talk about first, before talking about making the HDA, is a voxelization workflow in Houdini. So this tutorial will be divided into two sections. One is making the voxelizer at first, and then the next section will be to just turn that into an HDA with the right parameters and the UI, a flexible UI for other users to use. So what are voxels? The popular notion of voxels that we've all heard before is in games usually. So the famous voxel engine game Minecraft, and as you can see here, is only consisting of these textured and colored cubes. So this is the more popular notion of voxels, but if you go to the Wikipedia page for voxels, you see that it has this more general concept, and that is the representation of a value on this grid in 3D space. So if you just look at this photo here, you see that there's this 3D grid in the 3D space, and each of these grid blocks is called a voxel, and we can assign any type of value and any kind of value we want to this space partition, as you might call it. For instance, if you've been fiddling with Houdini before, you'd know that in Houdini, when you work with volumes, you have this density attribute on the volumes, which is this then density value that represents that certain voxel in space. But what we want to do today is just to stick with the more popular notion of voxels. So I found this website online. It's drewbooboo.com. I'll put a link in the description of the video, and here is kind of displays what we want to do in Houdini today, and that is to just turn any kind of geometry we have into a voxelized representation of that geometry. So here, for instance, you see that we have this torus, and if we play with this slider, which determines the resolution of that voxelization, you see that we'll have different kind of shapes. And definitely check this website out. I'll put a link in the description, and this is exactly what we want to do in Houdini today. So without further delay, let's dive into Houdini. Okay, so one thing I want to point out is that I've already saved this project into a folder, and this is usually a good practice because any kind of assets you want to import in your project file, you can do it using a relative path, which makes the project more contained, you might say. So for today, I've already done that, and let's start building our voxelization workflow. So at first, what we do is drop in a geometry node, dive in, And I'll bring in a file sub. And what I've already done is that you can see that there are this couple of folders beside my project file, and I'll just go into the geometry, the geo folder, and import the Pikachu OBJ. There you go. So the first thing we will do is drop in a subnet. And this is going to be the main container for all the process we will implement in this project. And this is the thing that we will turn into the HDA in the end. So let's rename this Voxelizer. And then just connect the file sub to the first input and dive in. So if you've already worked with subnets before, you know that in the default mode we have 4 inputs, and whatever the connection you make to whichever of these inputs, you will have them inside as reference like this. So for instance, we have our file sub connected to the first input, and we have the as you can see, the file 1 sub here. So what we're gonna do is that at first we just drop in a null sub, and this is usually a good practice to do that, just to make your project clean. So we call this in geo, and as you can see, the model and the geometry I'm referencing here, this is not centered, for instance, and for some applications you want to do some just like cleaning up before doing the actual voxelization, and for that we'll drop in another subnet and just call this pre-voxelizer and connect our null sub to the first input. So what I want to do here, and again, let's first drop in a null sub in geo. So what we want to do here is to clean up this geometry before feeding it into the voxelization process. And there are a couple of things I'd like to do here. First is that, as you can see, my object is not centered in my scene, and for some applications this could be useful. For instance, I first did this for a 3D printing job in our studio, and for a 3D printing job you might want to have some controls over the transformation, the size, and the positioning of your geometry. So for that, one thing I want to do is at first center my object in the scene. So for that I'll drop in a transform sub. Let's call this center geo. And what we'll do here is to just use, in Houdini there's this really useful expression called $CEX, and that gives you the centroid of your geometry. And for that, if we just subtract this from our transformation here, then you'll see that we'll have our geometry centered. So let's do this for the other axes. So subtract $CEY, and again subtract $CEZ. One thing I want to point out is that as you can see, this is not really the centroid we have is not really the center of our object, and that is because as you can see, there's this tail that we have that is kind of just ruining this for us, and just the object is not centered correctly. And that could be for another tutorial I might have, which is to find the center of the object based on its weight or on its volume, as you'll see. But for now, this is pretty good, and I'm satisfied with this for now. So this is just a centroid of the whole object, and we've put this in the center. One thing I'll do, and this is going to be useful when I'll turn this into an HDA, and that is to just give the control to the user to be able to toggle this process on or off. So for that, we'll use the switch sub, and then just feed your raw data into the first input and your process data to the second. So we just call this switch center geo, and as you can see here, if I just toggle this, and we're gonna just use this as a Boolean parameter, you can say, if you're coming from a programming background, and that is just true or false or 0 or 1. And here you can see that if I just put this to true or 1, my object will be centered. So this switch workflow is a really nice and handy workflow if you want to have toggles that just activates or deactivates some of your processes in your HDA. So this is looking good. Let's just add some more cleaning up. And one thing I want to add is that you can see right now my object is not placed on the floor, and again, for some applications like 3D printing, this is very useful. So let's add this ability to our HDA. So we're going to call this place on floor, and for that, the only thing we're going to use is the minimum position of our object, our geometry on the y-axis. And as you, if you just middle click here, you see that Houdini already just provides us these parameters. So we're looking exactly for this. This is the min position in the y-axis. So for that, Houdini provides us with an expression as well, and that is there's this function in Houdini. It's called bbox, which is short for bounding box, and for that you just need to reference your previous SOP, which is switch center geo. And as you can see here, there are a couple of parameters you can feed into this function and have different results. So what I'm looking for is dy min. Okay. So this will give me the minimum position of my geometry on the y-axis, and what I'll need to do is just subtract this from my transformation. And there we go. So we already have this object placed on the floor, which is nice. Okay, next thing I'll do is again bringing a switch sub and enable the same toggle workflow for this one. Okay, so call this switch place on floor, and again connect the process data to the second input. Okay, last thing I'll want to do before feeding my geometry into the actual voxelization process, and that is to give the user the ability to play with the size and the scale of the object. Again, this is useful for an application like 3D printing. So again, just put in a transform sub. Let's call this scale to fit. And what I want to do here is to play with this uniform scale and use expressions so that the maximum size of my object in any of the axes I have will be fit to the user given input. So for this, let's first Alt E. I'm bringing the expression box. What I want to do is, as for instance, I have a value of 3 as my maximum value. What I'll want to do is divide this by the maximum, which is the function in Houdini, which if you feed in 2 parameters, it will return the maximum and the larger of those 2 values. So for this, we'll ask for the size we have on the x-axis, and that is just reference the switch place on floor, which is the sub previous to this, and we'll ask for the dx size. And if we compare this with the result of another max function, which in turn asks for the other two sizes we have, this will be working correctly. So for this, again, switch place on floor, and this time we'll ask for the y size and compare this with another bbox function. Again, switch place on floor, and this time we'll ask for the z size. So close this person, this one, and this one. Yep, this is working correctly. So as you can see here, if I just change this value to 5 and middle click here, then I have my maximum size, which is in the z axis, as 5. So this is exactly what we were looking for. Again, let's put in another switch stop and enable the toggle workflow we have for the user. So switch scale to fit. Okay. Alright, so this is looking good as our pre-voxelization stage, and let's just drop in another null stop, which will be our gateway, our out of this sub network. So out geo, and turn on the display flag on this. Okay, so let's make our next stage here again as a subnet, and this is going to be called Voxelizer. Okay, dive in. Okay, another null sub. Alright, in geo. Okay, so what we want to do, let's just minimize this pane here. What we want to do here is that you remember that the voxels had this broader notion, which was concerning the different values you might have in that 3D grid, in the 3D space. But for this, the only thing we're looking for is that whether for a certain voxel we have that voxel intersecting with our geometry or no. So it's sort of like a Boolean value, and that is 0 if the geometry intersected with the voxel grid, or 1 if if it's 1, then the geometry had intersected with the voxel grid, and if it's 0, then the voxels were outside of geometry, you could say. So for that, Houdini provides us with this really handy sub, and that is called points from volume, which is here. And although the name says volume here, you can use this with the normal mesh geometry you might have. So as you can see in the source type parameter, you have different choices, and we'll just go with the auto detect parameter value for this. So one thing I want to point out is that you see this blue wireframe mesh, and this is just a guide. So if I middle click here, you see that I only have the points, and this is exactly what I'm looking for. So let's just rename this points from geo, and just for clarity's sake, let's just drop in another null sub. Call this out geo, connect these together, and there you have it. Just the points we were looking for, and they're placed exactly on that 3D grid that we talked about. So yeah, this is looking pretty good. Next thing I want to do is that at first I want to talk about the parameters I have on this sub, and there are a couple of parameters that could be interesting. The main one is this point separation parameter, which is the distance between each of the points. So in our case, you can also call this the voxel size. So if I just decrease this, you can see that I'll have this in a higher resolution. The 3D grid is more dense, you can say. And the other thing that I'll use later is this jitter seed and jitter scale. So this jitters the points you have here, and the seed is just a seed that decides how to jitter the points, and the scale is the amount of jitter you might have. So this could result in some weird looking, but could be useful in some cases. So we'll also use this later on. So the next thing we want to do is that we want to bring in a geometry and copy that geometry onto our points. And the classical look that we've all seen for a voxelized geometry is the box geometry. So if we bring in a box geometry, and what we can do here in Houdini is to use the copy to point sub. And whenever you forgot that, like for instance, in this sub, what are the inputs, or what kind of data you should provide, just hover the mouse on them, and you'll see that, for instance, here the first input is the primitives to copy, and the second input is the target points to copy to. So we'll connect the points we have to the second input and the box geometry to the first input. There you go. So we have our Pikachu. You can see it kind of vaguely here, but it's kind of obese, you can say, and there's a good reason for that, and that's that the box geometry we have, the size of that box geometry is a uniform size of 1, but we want to have that scaled down to the voxel size we have. So for that, let's drop in a transform sub. Just put it between the copy to points and the box geometry. So let's just call this box. Let's call this to scale to voxel size, and this is going to be copy voxel geo. Okay, so what we want to do here is to scale down, as I said, to our voxel size. So we already have this uniform size of 1, so if we just multiply this uniform scale to the actual voxel size we have, which is the point separation parameter here, we'll have the correct output. So copy parameter here, and then just paste relative reference here. Okay, so this is looking good. This is exactly what we're looking for, and you can see that this is pretty okay. One thing I want to add, and that's just for the user to be more flexible and have more just tools in their hands, and that is for them to be able to import their own custom geometry as the voxel geometry we want to copy. So here let's jump up 2 levels, and for instance, let's bring in a platonic. Okay, just choose the soccer ball, and if we look at it here, you will see that we have this really neat looking soccer ball. So let's just connect this to the second input of our voxelizer, dive in, and again we want to use the second input. Just connect this again to the second input of the voxelizer stage, again dive in, and just bring in this guy here. Okay, so what I want to do is that I'll just put in a switch sub here, and that will later enable me to give the user the ability to choose if they want to use the classical representation of voxels, which is the box geometry, or they just want to use their own custom geometry. So let's first just drop in a null sub here, call this in custom geo. Let's call this switch custom geo. Okay, so if I switch this, okay, you will see that we have our custom geometry, the soccer ball, copied onto our points. It's self-intersecting, and this is not good. We want to prevent that. And again, there's a reason for that. And if we middle click here, you will see that the size we have for this geometry is more than 1. And with the box geometry, we were fortunate enough to have this uniform size of 1, but we cannot be sure that we'll have that in the user-fed geometry. So let's make sure that our biggest size, sorry, our biggest size on our custom geometry is 1. For that, we'll drop in another transform sub. Let's call this scale to 1. And what we'll do is we did this in the pre-voxelization stage. Let's Alt E, and we want to just have the maximum size as 1. So again, let's divide 1 by the maximum of the B box coming from in custom geo. We want the X size. Compare that with another max function that compares 2 B-box functions. Again, in custom geo, and this time Y size. Let's compare this with the other B-box function. That is again in custom geo, and the Z size. Okay. Yep, this is looking good. So if we middle click here, you will see that our maximum size is 1, and this is exactly what we're looking for. So if we just feed this custom geometry into our previous process, the geometry will be scaled down to the voxel size here, and then we'll copy it to our points, and everything will look good. One thing I want to add is that if we again jump up 2 levels, or let's just do it here, the geometry we have here is centered in our scene, and this is crucial for the copy to points sub. So one thing I just want to make sure is that the custom geometry that the user feeds into our asset, it's going to be centered before it's being copied onto our points. So for that, let's drop in another transform sub. And again, we did this in the pre-voxelization stage, and for that, let's call this center custom geo. We're going to use the subtraction of $CEX, and same thing here for Y and for Z. Okay. So this is looking good. Let's just connect this to the out geo sub we have. One last thing I want to add to this process, and that is because you might want to use this for real-time applications, and for that this geometry is filled with all the voxels. But sometimes you might not want the interior voxels, so let's just specify a process for that deletes the interior of our voxelized geometry. So let's just bring this back to the good old box geometry. Okay, so one thing I just want to tell you before doing that is this pack and instance parameter on our copy to point sub. And like for now, if we middle click, you'll see that we have lots of points and primitives. But if we just check this box, we still have the many boxes that we wanted, but now it's really more lightweight and easier to work with. So as you can see, we have only 18,027 points, and we have the same amount as packed geos. And this is rightfully in Houdini, this is called instancing. If you're coming from a real-time graphics background, you will be pretty familiar with this as well. And we have instancing there as well. So it's just points that later in the like the rendering stage or in the viewport, they will be instanced using the geometry that we assign to them. Okay, so this is going to be one thing that later on I'm going to just use and publish for my user. So for now, let's check this, and let's start removing or giving the user the ability to remove the interior. For that, I'll just drop in a Vex snippet sub, and that is the wrangle sub. Okay. So what we want to do here is to just process all of our points and then try detecting the neighbors of those points. And then if the neighbors count were more than a certain amount, then we'll be sure that that voxel is inside and it's part of the interior, and then we can just delete it easily. So for that, I'll just define this value, this integer value, as the neighbor count. Let's put this to 0 first. So what I'm going to do is that I'm going to, for each of the points, I'm going to scan the neighbors, and for that I have to have the voxel size value here, so I can search based on that size, and that's going to be the radius of my search. So let's just bring in this float voxel size. This is going to be a channel function which asks for this voxel size. Okay, just press this button, and then we have this as a parameter on our sub. So again, copy this voxel size that we had before, copy this parameter, and then just paste relative reference here. Okay. So the next thing we'll do is that we're going to search for the neighbors, and for that, let's bring in the neighbor count again. And Houdini has this function called just near points. And whenever you forgot, just if you go into the Vex reference in Houdini, you can read more about that certain function. So for here, we'll know that we will need to specify the geometry stream we have and the data stream, and that is 0, the first input. And we will provide the position we're looking for as our center of our search. And the radius will be the voxel size. Multiply it by a number like 1.1. So because we want to go further than the really like the voxels we have beside our point. And let's just do it here. Okay. It's not, oops. It's complaining. Okay, so one thing I forgot was to, if I just put a len function, and that is that in Houdini that returns the length of an array. So with near points function, it returns an array of all the points that are in that search radius we provided. So if we just use the length function, it returns the length of that array, which is the neighbor count we're looking for. Okay, so the last thing we will do is to just group the voxels and the points we have based on this neighbor count. So if neighbor count is more or equals 7, then we can group this, and this is the syntax you will use in Vex to have groups. So if I'll just call this @group underline interior to 1, and else we'll have again the group the line interior is to 0. Okay, so as you can see here, we have this 14,000 something points in our interior group, and this is the group that we can delete in order to just free up the space inside and have this more lightweight object we're looking for. So let's just call this group interior, and the next thing we'll do is to use a delete sub. Delete interior, and entity will be points, and the group will be the interior we have. So if we go inside, you'll see that our voxelized geometry is now empty, the interior is gone, and this is exactly what we're looking for. So but let's just, before we move out of this stage, let's just again use the toggle workflow we had before, and later on give the user the ability to switch if they wanted to delete the interior or no. So for that, drop in a switch sub, let's bring this here, call this switch delete interior, connect this and this to the second input. Okay, so if you immediately click here, we have 18,000 points, but if we just toggle this to 1, we'll have 3,000. So a lot of our points were in the interior, and now this is cleaned up, which makes it a more lightweight geometry. This is looking good. Let's dive out and let's just go up one level. All right, so the last thing I want to add is this post voxelization stage, and that's to, let's just bring in a subnet, call this post Voxelizer. Okay, and one thing I'll add is to drop in an all sub and call this out geo. Okay, so what we want to do here in this post voxelization stage, that is to just, if we can, define some again features for our HDA that could be useful. So one thing I can notice here is that although we have our geometry voxelized pretty good, one thing that I'm missing here is that as you can see, we don't see the edges properly. So these edges and seams between each of the voxels, so like for instance this one, you can see it as one block, although it's a multiple amount, it's a multiple count of box geometry that we have. So we want to add this feature to our HDA, so let's do that. So in Houdini there's this really handy sub called carve, and what it does is that it turns your mesh geometry into polylines, as they call it in Houdini. So let's just connect these two, call this carve geo, turn on the display flag, and you see that this is not working. And why is that? So there's a reason for that. If we middle click here, you remember that we packed our geometry in our previous stage, and the packed geos won't work with carve sub, you first have to unpack your geometry, turn them into a regular mesh, and then carve will work correctly. So for that, just drop in an unpack sub, and there you go. So we have our edges here as polylines, and if we merge these two together, so we have our voxelized geometry to our first input, call this merge with edges, and if we connect these together, you'll see that apart from the box geometries we had for voxels, we now have this edges as well, which is nice, which is what we're looking for. So just to just enhance this a little bit and just to be helpful to the users, let's first do one thing, and that is to group these two streams into separate groups. So this is going to be called group voxels. The group name is going to be voxels, and let's put in another group sub. Group edges, and call this edges group. Okay, this is looking good. One thing I want to add is that for now, if we just turn on the display flag on carve, you will see that we have this edges as polylines, and sometimes this is okay for you, but sometimes you might want to have them as mesh geometry. So for that, Houdini has this sub called polywire, which we're going to use right now. And what polywire does is that it turns your polylines into actual geometry, but line geometry or wire geometry. So if you just turn the display flag here, turn it on, and you can see it's kind of looking weird, and this is because of the wire radius we have on the polywire. So if you just, let's 0.005, okay, this is looking good. And again, later on, we're going to publish this wire radius so the user can decide what will be the radius of their polywired mesh. Okay, let's just rename this sub to polywire edges. And one last thing I want to do again, like before, I want to have this toggle workflow for these as well. So if I'll just put in a switch sub. At first, I want to have the toggle workflow for the edges themselves in general. So if the user want to have the edges merged or no, so we just put this here, drop in a null sub, and call this nothing. This is going to be a dummy geometry. And let's just switch these two inputs. So let's call this switch edges. And so as you can see here, if we toggle this to 0, we won't have the edges anymore, and if we toggle this to 1, we will have the edges. One last thing I want to add is to also toggle this polywire process, and for that, again, another switch sub, bringing your carved geometry here to the first input, switch polywire, rename this, and your polywire edges sub to the second input. Let's just connect this here. Okay, so if we toggle this to 0, you'll see that it's just the polylines, and if we toggle this to 1, we have the mesh geometry here. Okay, this is all looking good right now. One last step, drop in an all sub. Let's call this out geo and turn on the display flag here. Okay, so there you go. One last thing I want to just try is to see if my grouping was correct, and that is to drop in a color sub and just color the edges as black. Yep, there you go. This is working correctly and looking nice. So this section of tutorial is over right now. For the next section, I'm going to talk about turning this subnetwork we have, this Voxelizer, into a full-on HDA. Okay, so for this section of tutorial, as I promised before, we're going to turn this set of processes that we had and turn them into an HDA. For that, let's first start building a user interface. And Houdini gives us this edit parameter interface option here on the gear button. And if we press this, we'll see the parameters we have on our subnetwork and on each of the nodes. So at first, what I want to do is to hide these 4 parameters. We're not gonna need them. So just select them all and check this invisible box checkbox here. There you go. These are gone. If I hit apply, I can see them no more. What we want to do is to first find the parameters that we want to publish to our topmost level. And for that, let's first just inspect what we did in our last section and use that as our starting point. So if we, again, as you guys remember, we had this pre-voxelizer stage, the voxelizer stage, and post-voxelizer stage. And in each of these, we have different sets of parameters that we want to use. So the first thing I'll do is to, again, go into this edit parameter interface. And I want to just separate these stages I have inside and separate them in my UI as well. So for that, we're going to use this parameter type called folder. So folders are a really handy and useful way of just dividing your parameters into different groups. So for that, we have different looks even, so collapsible symbol tabs and so on. So we're going to go with the simple look for now. So let's just call this pre-voxelizer. It's going to be our first stage, and then another folder. Let's call this post-voxelizer. You can also copy and paste this. Call this Voxelizer. Okay, let's just put this here. All right, so let's dive in and see what parameters we want to publish. Okay, in the pre-voxelizer stage, the things that I want to have and I want to give the user the ability to control are these 3 switch buttons or switch subs. And one thing is the amount for this scale to fit sub, transform sub. So this amount here should also turn into a parameter that is controllable. So let's go up 2 levels, and again, edit parameter interface. And in the pre-voxelizer, I'm gonna have 3 toggles that represent my switch subs. One is going to be named, I'm gonna just add this prefix of pre-voxelize. Pre-voxelize switch center geo, and this is going to be center geo with a question mark. I like it this way, so it's apparent that it's going to be a toggle. It's a question. And for the next one, we'll call this switch place on floor. Let's call this place on floor. And for the third one, we're gonna have switch scale to fit. Scale to fit, question mark. Okay. One last thing, as we saw, we need a float parameter that is going to control the size of my scale to fit sub inside. So it's going to be named pre-voxelize scale to fit value. As a label, we can call it maximum size. All right. And one thing I want to point out is that for parameters in Houdini, you have this channels tab, which you can define a default value. So for the default value, I'm going to go with 1. And this is pretty useful. So let's just hit apply. And as you see, we have this pre-voxelizer stage just separate from the others in this box. And we have 3 toggles and 1 float. One thing I want to do is that if the user just does not check this scale to fit box, then we don't need to enable this parameter as well. We can either hide this when this is not checked, or we can disable this. So for now, I'm going to go with disable. As we go forward, I'm going to also show you guys how to hide parameters based on toggles. So for this, what we'll do is to go into this parameter, and there's this disable when parameter that we'll use. So for this, we're gonna say, okay, if this parameter, which is scale to fit, if this is 1 or if this is 0 actually, then we'll need to disable this. There you go. So if I just check this box, then it's going to be enabled. If not, this is going to be disabled. This is exactly the behavior we're looking for. One thing I just noticed is that I didn't save this label. So again, center geo, enter. And this is looking good. Let's just assign these parameters to the toggles and the float parameter we have inside. So say accept, just copy this. And what I'm going to do is to control 1. So I have a quick mark set for this level, and control 2. So I have a quick mark here as well. All right, so paste relative reference for the center geo. 1, and copy this. 2 again. We'll paste the relative reference to the switch place on floor. 1 again. Copy this guy. 2, and switch scale to fit. Paste relative reference. And the last thing we'll do is to just copy this. And what I'm gonna do is to just bring this value and replace the fixed value I had here with this parameter. So Alt E. And if I just ask for it using the channel expression, so if I go 1 level up, 2 level, and we have this parameter here, which was called pre-voxelize scale to fit value. Just close this. Okay. And if we again just press 1, and we center geo, you see that this is centered correctly. Place it on floor and scale to fit. So this is 1 now. Let's just have this 5. This 5, and there you go. So our pre-voxelizer stage is set. We saw that how we can have toggles and float parameters assigned to the process we had inside. So let's go to the other stage that we had, Voxelizer. Again, I'll control 2. So I have this one replaced with the other stage. And the things I want to publish are a couple of things here. One is the point separation or the voxel size, and these two guys, which are the jitter speed and jitter scale. And the next thing I want to have, let's see, I want to have this switch stop enabled, so the user can provide and can decide if they want to provide their custom geometry. And what I want to do is to also publish this toggle, which decides if the process should delete the interior or no. Okay, so what I'm gonna do, and this is another way of making parameters, and this is a really useful way actually. So what I want to do is to go into this from nodes tab here. And from nodes, what it does is that you can reference the parameters you already have on the other nodes inside, and you can just reference them here on your base SOP. So for this, I'll go to the Voxelizer stage and the points from GeoSOP, and there you see that I have these parameters. For instance, the point separation that I was looking for, and the jitter speed and jitter scale. So if I just bring these guys here, you'll see that I have them here. I just need to change the name for the point separation, so it's a familiar name. So I'm going to go with voxel size. Okay. And I also can change the name of the parameter. I'm not going to do it right now. So these are looking good. So if I just click apply, you'll see that I have these parameters here. Why is it not looking the same as the pre-Voxelizer? And that's because I have to change the folder type to simple. And there you go. We have this here. What I want to show you guys is that if I dive in to the Voxelizer stage, you'll see that on my points from Geo, I have these three parameters that I selected referenced correctly, and this is a really handy way to do that. Okay, so the next things I want to do is to also bring in these two toggles. So press 1, go here, and then edit parameter interface, again from nodes, Voxelizer stage, the switch custom geo, and I only have one parameter here, so let's just place it here. And also this switch delete interior, and I have this here. Okay, so let's just rename this to custom geo, and this guy should be called delete interior. Okay, so if I click apply, you will see that these guys appear here on the Voxelizers tab and Voxelizer folder, but they're not looking correct. They're just they're like integer values that we have, and this is right. This is correct when looking at it from the perspective of the switch stop. But what we want to have is just a toggle. So Houdini also provides us with this handy feature that you can change the type of the parameter. So if I just change this into a toggle, this one as well, and hit apply. Okay, so I have these two guys as toggles. So if I just hit the custom geometry and check this box, it will say that this is taking so much time just to polywire the edges, and there you go. We have this along with the edges, the custom geometry we had. Okay, so this is also working correctly and as I imagined. So the next step is the post Voxelizer step. So let's also do this. And again, for this stage, I'm gonna go with the first method I use, which is to first define the parameters and then reference them inside. So let's see just what kind of parameters we need for this stage. Let's just come back, just uncheck this box, and dive in. Alright, so here the only things I'll see are these two switch stops that could be very useful. One was to switch the polywire process, and one was to just switch the merging of the edges geometry with the main geometry. Okay, so we're just gonna need two toggles here again. Okay, one is going to be called post voxelize switch edges, and we just write it as edges with a question mark, and the other's name will be switch polywire question mark. One thing I forgot to, oops, let's just correct this. One thing I forgot to add was, as you remember, inside the polywire stop, so if I dive back in, we had this wire radius parameter, which was really useful for us, so we're going to publish that as well. So dive back, and we have this. Let's bring in a float parameter for this and call this post voxelize polywire width. Let's call this polywire width, and again let's just put in a default value. So the default value I'm going to go with 0.005. Hit apply, and what I need to do is to just reference these inside my reference processes. So copy parameter here, post voxelizer. This was the edges, so I just need to, let's first control 2 here. So I just paste the relative reference here. This was the switch stop that decided if I want to go with the dummy geometry or the edges geometry, and how I want to merge them. Again, 1, copy this guy, and we need to paste this here on the switch polywire stop, and go up and copy this guy, again 2, and then just bring this here. Okay, so let's first see if this is working correctly. So if I just bring the edges, you'll see that I have them here as polywires, which is the desired function. And if I just check the polywire, you'll see that I have them as meshes. So the previous one was polylines. Sorry if I said it wrong. And this guy is decides if these are going to be meshes or not. So the last thing I want to do, and which sounds logical to me, is to I can only polywire my edges if I already have this one checked, and I can only decide what's the width of that polywire if I've already checked this one. So I'm going to just reference these and connect these together in a way that I can only see one if the other one is checked. So for this, we're going to go to the edit parameter interface, and in the parameter tab for the polywire, I want to have this hidden, and this is how we use the hide when, and I want to have this hidden if this guy was 0 and if this toggle was not checked. And for the polywire width, we're going to have this hidden again if this polywire toggle was 0. So in the hide when tab parameter, we're gonna just say if it was 0, then just hide this guy. Okay, so if I uncheck this box, the width is going to disappear, and if I uncheck this guy here, the polywire checkbox is going to disappear. So this is the desired behavior that we were looking for. Okay. So, and one last thing, this is looking different, and this is because the folder type we have is set to tabs. We want it to be simple. Okay, so there you go. So this is our user interface for this Voxelizer asset. Last thing but not least is that we have to turn this into an HDA. So let's just right click here, create digital asset, and just name it. I'm going to call this M Voxelizer. Let's just call this KINO and Voxelizer. And it's the default path is going to be your OTLs folder, which is the folder that's in any of the Houdini sessions you'll have. You can reference this. You can also decide to only save this asset as a local asset just for this project. But for this, we're going to save this to the library, to the main path for the library. So hit accept. Okay, so we're going to have this window open for us. And in this window, one thing that is important and we should decide is the minimum inputs and maximum inputs parameters. So as you remember, we had the second input here, but this is an optional input. We will only need this if the user wants to provide custom geometry. So let's just keep the minimum inputs to 1, and this is the mandatory count of inputs that we need to have for this sub to work. But the maximum inputs, let's just leave it to 2. So this says that I will only need 1 input to work, but if you want, you can also provide another just data to my second input, and the asset will work correctly. The maximum outputs is of course set to 1 because we only have 1 stream of data coming out, and that's is looking correctly. And if you go to the parameters tab, you see that we have all the parameters that we wanted. And this is looking okay. I don't need to. These are also really handy. I will talk about them in future tutorials. But for now, this is all we wanted. And this is looking okay. So as you see, we have this HDA LC. This is because I have an indie version of Houdini limited commercial, but the for the commercial version, you have only the HDA. So let's just click accept, and there you go. We have our HDA here. So if I just hit tab and say KINO, and you see that I have my Voxelizer here, and I have 2 of them because I had this one saved beforehand. So this is looking okay, and I guess the tutorial is finished. So you have all the info you might need. Of course, if you like this tutorial, you can always buy me a cup of coffee using the link in the description. And I hope you guys enjoy the rest of the day. Goodbye.